Hi students, today we are going to see assumption concept 3 sum number 7. Already we have completed 6 sums. Now we are in the sum number 7, right? The perimeter of a sector of a circle of radius 5.6 centimeter is 27.2 centimeter. Find the area of the sector, right? Find the area of the sector. So given and to find. So to find what we want to find, area of a sector, right? Area of a sector. So what is the formula of area of sector? Theta divided by 360 into pi r square. So if we know the value of theta, that is nothing but angle of the sector, theta and radius of the sector. If we know the theta and radius, then directly we can, using the formula, we can find the area of a sector, right? But here, what are things we are having? First we will write the given. The perimeter of a sector of a circle of radius 5.6 centimeter is 27.2 centimeters. Circle of radius is nothing but 5.6 centimeter is 27.2. What is 27.2? The perimeter of a sector of a circle, right? The perimeter of a sector of a circle. So here radius of a sector is nothing but 5.6 centimeter, right? 5.6 centimeter, and the perimeter of a sector, that is perimeter, right? Perimeter of a sector, I am denoting perimeter as P. P is equal to 27. Perimeter of a sector is equal to 27.2 centimeter, right? Perimeter of a sector. So, but for finding the area of a sector, what are things we are needed? Theta and radius, right? Theta and radius. But we are having only radius, there is no value for theta, right? We don't know the value of theta. But instead of finding the theta, right, they have given a clue. What is it? Perimeter of a sector is given. Perimeter of a sector is given. So by equating the, yes, we know the value of a perimeter of a sector. By equating the formula of a perimeter of a sector with this value, then we'll get the theta, right? We'll get the theta. But here we are having two formula to find the area of a sector. One is something about theta divided by 360 into pi r square. Another one is something about half into L into R, right? Half into L into R. What is the formula for perimeter of a sector? Perimeter of sector is something but P is equal to theta divided by 360 into 2 pi r, right? Theta by 360 into 2 pi r plus 2r, right? Plus 2r. Perimeter, this is nothing but length of an arc, L, right? Length of an arc plus 2 radius. That is nothing but perimeter of a sector, right? Otherwise, we can use one more formula. P is equal to L plus 2r, right? L plus 2r, right? So, by using this formula, we can find theta. Otherwise, by using this formula, P is equal to L plus 2R, right? By using this formula, we can find the value of L, right? For finding the area of a sector, whether you can find theta. If you are finding the theta means, then we want to use the formula theta by 360 into pi r square, right? Theta by 360 into pi r square. Suppose you are using this formula, perimeter of sector is L plus 2R. Right? By using this formula, you will find now you know the value of radius. By equating with this value, right? By equating this value, we will get the value of L. That is the length of arc. If you are finding the length of an arc, right? If you are finding the length of an arc, then we can use a formula half into L into R. What is the formula of half into L into R? Area of a sector. So if you know the L and if you know the radius, directly we can use this one. So that's your wish. Here I am going to use perimeter of a sector formula is something but L plus 2R. I am going to equate with the L plus 2R is equal to 27.2 centimeter and I am going to find the value of L, right? Perimeter of a sector is equal to 27.2 centimeter. And already we know that, right? We know that perimeter of a sector is equal to P is equal to L plus 2R, right? L plus 2R. So instead of P, what I am going to write? L plus 2R. I'm just equating, right? L plus 2R is equal to 27.2, right? So what is the, already we know the radius. What is the value of radius? 5.6. Substitute here and simplify. L plus 2 into 5.6 is equal to 27.2. L plus 2 into 5.6. How much? 11.2, right? 11.2 is equal to 27.2, right? Taking 11.2 the RHS, then plus 11.2 will become minus 11.2. So L is equal to 27.2 minus 11.2 is equal to 16. So L is equal to 16 centimeter. What is L? Length of an arc. If we know the length of an arc, then we know the formula half into L into R. Area of a sector is equal. By using that formula, therefore, area of a sector is equal, right? Area of a sector is equal to half into L into R, right? We know the value of L and we know the value of radius also. Substitute and simplify, will get the area of sector. So it's nothing but half into, what is L? 16. 16 into 5.6 centimeter, right? 5.6 centimeter. Well, we are simplifying 1 times 8 times. So 8 into 5.6 centimeter is equal to, right? By multiplying these two, 44.8 centimeters square. Therefore, area of a sector is equal to, right? Area of a sector is equal to 44.8 centimeters square. So number 8. A pendulum swings through an angle 60 degree and describes an arc 8.8 centimeter in length. Find the length of the pendulum. Find the length of the pendulum. So first of all, you can draw a diagram. How the pendulum will be. How the pendulum will be. Something by it. It's a physics, right? Physics concept. Pendulum, right? A thread with a small ball, right? This is nothing but pendulum, right? A pendulum swings, right? A pendulum swings means, how it will be swings? Like this it will swings, right? It will swings like, and this is a pendulum, right? While this swings means it moves, what is it, left to right, right? Moves left to right, like this it will swings, right? A pendulum swings through an angle. Up to how much angle it is swings? It swings 60 degree, right? It forms a 60 degree. Up to 60 degree it is swinging, right? It swings angle 60 degree and describes an arc, right? And describes an arc, and this is nothing but an arc, right? And this is nothing but an arc, describes an arc of length 8.8 centimeters. So this is nothing but the length of an arc is nothing but 8.8 centimeter, right? Length of an arc is nothing but 8.8 centimeter. Find the length of the pendulum. This is nothing but length of the pendulum. Length. And this is nothing but length of the pendulum, right? Here also the same length and here also the same length only, right? Here also same length and here also the same length, right? I'm just giving the name OA and this is nothing but OB and OC, right? OA, OB, OC, all will be same length, right? Whatever the length is there, up to that level alone it will be swings, right? So OA, OB and OC will be equal. Here we want to find the length of the pendulum. See, by swinging the pendulum swings means we got a sector, right? We got a sector. Now we want to find the length of the pendulum. What is here? What is length of pendulum? In this diagram, what is length of pendulum? It's nothing but radius of a sector, right? It's nothing but radius. Length of the pendulum is nothing but radius of a sector, right? Radius of a sector. So now what we want to find? Radius of a sector only we want to find. How we are going to find? Now we know that we are having, what is it? Theta is equal to 60 degree. And one more thing, 8.8 centimeters. Nothing but what is it? Length of arc. Yes, length of an arc. We know the length of an arc is nothing but 8.8 centimeter. Length of an arc is nothing but L, right? By equating L formula with this value, we will get radius, right? See, they didn't talk about anything sector, segment, or what is it, circle, semicircle, or they didn't talk about anything. Simply they have given some instruction. That's something but what is it? A pendulum swings through an angle 60 degree. Up to 60 degree it was swings and describes an arc. Describes an arc is nothing but 8.8 centimeter in length, right? And we want to find the length of the pendulum. Only we want to find the length of the pendulum. See, for this situation, we have, it's something but it is created a sector. So by using the sector formula, we are finding, right? So given, what are given we are having? Theta of a sector, right? Theta of a sector is nothing but how much? 60 degree. And length of an arc, that is nothing but what is it? L. Length of an arc, L is equal to 8.8 centimeter, right? 8.8 centimeter. Length of an arc is nothing but 8.8 centimeter. Now, what we want to find? What we want to find? Length of the pendulum. What is length of? What is here? What is mean by length of the pendulum? Length of the pendulum is nothing but radius, right? Length of the pendulum is nothing but radius of the sector. So how we are going to find? We know that yes, L, length of an arc formula. By using length of an arc formula with this value just equating, and we are going to find the radius. So L is equal to 8.8 centimeter. L is equal to 8.8 centimeter. So already we know formula. What is L? Already we know the formula. L is equal to theta divided by 180 into pi r, right? Theta divided by 180 into pi r. Substitute and simplify, we'll get the answer, right? So theta is something, what is it? Theta divided by 180 into pi r. Pi r is equal to 8.8 centimeter. 8.8 centimeter. Substitute the values. See, we can change this 8.8 as in terms of a fraction. See, this is in the form of decimal. If you are changing in terms of fraction, it will be easy to simplify. So what I am doing, 88 divided by 10 centimeter, right? So I am just going to write this as, substitute the value of theta and pi value, and just simplifying and taking to the RHS, will get the value of radius. What is the value of theta? 60 degree. So 60 divided by 180 into 22 divided by 7 into r is equal to 88 divided by 10. Right, 88 divided by 10. Simplify. 0 will get cancelled. 6 table. 1 times, 3 times. Right. Is there any possible to simplify? Nothing is there. So you can write as it is the remaining things. It's nothing but 22 into r divided by 3 into 7 is equal to 88 divided by 10. Right. Keep the r alone in the LHS. Remaining all you can take it to the RHS. Right. Multiply will become divide. Divide will become multiply. Numerator will goes to denominator. Denominator will goes to numerator. So keep the r alone in the LHS. Remaining all you can take it to the RHS. What is already in RHS? 88 divided by 10. Right. So 22 taking to the RHS, multiply will become divide. Right. 10 into 22. 3 into 7 goes to numerator. Right. So 88 into 3 into 7. Right. Is it possible to simplify? Yes, 22 table can cancel it 1 times, 4 times. 22 4s are 88, right? Still we can simplify, but you can keep as it is, just multiply and divide divisible by 10 means before 1 point we are keeping the point, right? So r is equal to 4 into 3 into 7 divided by 10. 4 3s are 12, 12 7s are 84. So 84 divided by 10 is equal to 8.4 centimeter. Therefore, the length of the pendulum, the length of the pendulum is 8.4 centimeter, right? Next, a very important note, right? And this is a constant, right? Constant angles, right? This is the constant angles. See, angle described by minute hand, right? Minute hand, right? You know, minute hand and hour hand in a clock. Yeah, biggest hand is called minute hand, and small hand is nothing but hour hand, right? Hour hand. So minute hand and hour hand. Angle described by minute hand in 1 hour, right? In 1 hour is equal to, right? This is nothing but a clock, right? This is nothing but a clock, right? A minute clock, a minute hand, right? For 1 hour, this is nothing but 12, 6, 3, 9, right? This for 1 hour, right? It will clockwise, it will rotate a 1 round fully, right? It will complete 1 round fully, right? What is the complete angle of a clock circle? 360 degree, right? So once, if the minute hand will cover in 1 hour is nothing but 360 degree, right? Minute hand in 1 hour, the angle described is nothing but 360 degree, right? It will rotate full circle. It will rotate a full circle. The angle of a full circle, it's nothing but complete angle is nothing but 360 degree. 360 degree, right? Angle described by minute hand in 1 minute, right? Minute hand in 1 minute. For 1 minute, how much angle it will be described, right? How much angle? Something by circle, and this is nothing but minute hand, right? A minute hand described an angle for 1 minute, right? Described an angle, this is nothing but 1 minute. Described an angle is nothing but 6 degree. It's nothing but the complete angle of a circle is nothing but 360 degree, right? And the total minutes for 1 hour is nothing but 60 minutes. While we are dividing, 0 cancel, how many? 6. For 1 minute, how much angle the minute hand is describing? 6 degree. For 1 minute, how much angle it is describing? 6 degree, right? For 5 minutes means, for 1 minute it is 6 degree means, for 5 minutes, how much angle it will describe? 5 into 6 degree is equal to 30 minutes, 30 degree, right? So theta is nothing but 30 degree. For 5 minutes, how much angle it can describe? 30 degree, right? For 1 minute it is 6 degree means 6 into 5 minutes. 12 minutes means 12 into 5 degree is equal to 6. 12 into 6 is nothing but 72 degree, right? 12 into 6. For 1 minute it described the 6 degree angle. For 12 minutes it's nothing but 12 into 60 degree. Just we want to multiply, right? For 12 minutes, how much angle it can describe? So the complete angle is nothing but 360 degree. For 1 minute, how much angle it can describe? 6 degree, right? So same thing, it's nothing but minute hand. Hour hand in 1 hour, right? Hour hand, how much angle it can describe? So for totally 12 hours, right? Totally 12 hours, it will complete a circle, right? It will complete a circle in 12 hours. So the complete angle is nothing but 360 degree. So 360 divided by 12 is equal to 30 degree. For 1 hour, right? For 1 hour, right? For 1 hour, how much angle it can describe? 30 degree, right? How much angle? 1 hour. So for 5 hour, the hour hand, how much angle it can describe? So 5 into number of hours into, for 1 hour 30 degree, then 5 hours in the minute, 5 into 30 is equal to 150 degree it can describe. Understood? This is very important. Minute hand in 1 minute and hour hand in 1 hour. This is a constant, it won't get changed, right? It's depending upon number of minutes we want to calculate, number of hours we have to calculate, right? So minute hand in 1 minute is nothing but 6 degree. It's a constant, right? Hour hand in 1 hour is nothing but 30 degree, right? See, that clock oriented sum, right? Clock oriented sum, they won't give theta. They won't give the value of theta, right? They won't give the value of theta. We only want to find the value of theta. For that, we want to know this, the basic constant things, right? These basic things. So minute hand in 1 minute is nothing but 6 degree. Hour hand in 1 hour is nothing but 30 degree. So depending upon the number of minutes or number of hours, we want to find the theta, right? We'll see one example sum. Sum number 9. The minute hand of a clock. Minute hand, right? The minute hand of a clock is 12 centimeter long. Find the area on the face of the clock described by the minute hand between 8 a.m. and 8:35 a.m. So what we want to find? Find the area on the face of the clock, right? Find the area on the face of the clock described by the minute hand between 8 a.m. to 8:35 a.m. right? So we want to find the area on the face of the clock described by the minute hand between 8 a.m. to 8:35. That is 35 minutes. 8 a.m. means it will be in the minute hand will be in 12. 8:35 means the minute hand will be in the 7th place, right? And this area fully we want to find, right? This area fully. And this is the what is it? Area of a sector, right? Area of a sector. For finding the area of a sector, we want to use what formula? Theta by 360 into pi r square. So if we know the value of theta and radius, right? If we know the value of theta and radius, then by using the formula directly we can find, right? But they won't give you directly, right? See here, we don't know the value of theta as well as we don't know the value of radius, right? But just now only we go through that. What is it? We can find the theta based on the, what is it? Minute hand sum, right? And theta is nothing but for each minute the minute hand describe an angle is nothing but 6 degree, right? For each minute the minute hand describe an angle is nothing but 6 degree. So here totally how many minutes? 35 minutes. So for 35 minutes, how much angle it has been described, right? For 35 minutes, right? 35 minutes, right? How many? 8 to 8:35 is nothing but 35 minutes. For each minute, right? For each minute, how much angle it is describing? 6 degree. For 35 minutes, how much angle it can describe? So 6 into 35. 6 into 35 degree. So 35 into 6 is nothing but 210 degree, right? 35 minutes, how we have find it? 8 to 8:35. So totally how many minutes? 35 minutes. For each minute, how much angle it is describing? Which is describing? Yeah, minute hand, right? 6 degree, right? They are talking about minute hand, right? If it is a hour hand means we want to go with the hour hand. For each hour, it describing 30 degree, right? Just leave that. Here we are talking about only minute hand, right? For each minute, how much angle it is describing? 6 degree. So the total 35 minutes, we want to find the area. For 35 minutes, how much angle it is describing? 6 into 35 is nothing but 210 degree. So theta is nothing but 210 degree, right? Major sector. And we want to find the radius. See, we are having radius. It's nothing but the minute hand of a clock. This is nothing but minute hand of a clock is 12 centimeter long, right? 12 centimeter long. This 12 centimeter long. The minute hand is nothing but the length of the minute hand is nothing but radius of a sector. So R is nothing but 12 centimeter. R is nothing but 12 centimeter. Now what we want to find? We want to find the radius of a area of a sector, right? We want to find the area on the face of the clock described by the minute hand between 8 a.m. to 8:35. So we want to find the area. To find what we want to find? Area. Here what shape is this describing? Area of a sector. So what is the formula of area of sector? Area of sector is equal to theta divided by 360 into pi r square, right? Theta by 360 into pi r square. We know the value of theta. What is the value of theta? 210 divided by 360 into pi value is something but 22 by 7 or 3.14. See, radius is not in form of 7 multiple. But see that theta, now theta is nothing but it is in the form of 7 multiple. So what I am going to use the value of pi. Pi is nothing but 22 by 7 I am going to use it, right? Because here theta is a 7 multiple. That's why I am using here pi is equal to 22 by 7 into what is the value of r? R is nothing but 12 centimeter. R square is nothing but 12 into 12. 12 into 12. Now you can simplify 0, 0, cancel. 7 table 1 times, 3 times, right? And 3 table 1 times, 12 times. 12 3s are 36. And 12 table 12, cancel. So what is the remaining? 22 into 12. So 22 into 12 is equal to how much now? 22 into 12 is equal to 264 centimeters square. Therefore, the area on the face of the clock described by the minute hand between 8 a.m. to 8:35 a.m. is 264 centimeters square. That's all, right? Thank you. Not on your homework sums.